right, here we go. Pair 2. Y equals 4x. And y equals negative 0.25x. So my x and my y, 0 and 1. 0 times 4 is going to be 0. 1 times 4 is going to be 4. All right, so 0, 0. And 1, 4. There's that. And then same thing here, x and y, 0 and 1. 0 times negative 0 is 0.25, it's going to be 0. And 1 times that's going to be a negative 0.25. All right, same process, got my 0, 0 here, and then 1, and then negative, so I have a 1, and then negative, that's going to be hard to do a fourth there, but see, maybe that's a fourth. So in this case, yeah, I didn't get it exact, but it looks kind of close to being perpendicular. Let's try number, or pair 3. All right, here we go. Pair 3. Got my two equations. Gonna put 0 and 1 in for x. So here we go. Negative 3 times 0 is gonna be 0. So I'm left with this plus 5 here. That's gonna be our y-intercept, gonna be different here. I put a 1 in here. Negative 3 times 1 is negative 3. Plus 5 is gonna give me a positive 2 in that case. So let me just plot those. So we got 0 and 5. So 0, 1, 2, 3, 4, 5 as there. And then 1 and 2. 1 and 2. So let's draw this guy out here. And then same thing for our second one. X and y. So 0 times 1/3 is going to be 0. Minus 1 is going to give us a negative 1. 1 times 1/3 is going to be 1/3. Minus that's going to be a negative 2/3 in that case there. So let's plot those points. 0, negative 1. 0, negative 1. And then after that, we've got a 1 and a negative 2/3. So it's going to be not halfway, but a little bit past that. Around there. Let's see what that looks like here. Hopefully I'm plotting it okay. So it looks to me like this is pretty close to being a right angle here. This might not be exactly the right angle here, and a right angle here. So what patterns did you observe in the graphs? When lines have opposite multiplicative inverse slopes, the graphs will be perpendicular. That's what we're noticing in that case there. So then it says, part 3, describe another pair of lines that would have the same pattern. So basically what we're seeing here again is this idea that the slope is going to be one thing, but then you have the opposite multiplicative inverse or the opposite reciprocal. So if I have like a 4, like we had in pair 2, then I would have to do 1/4 and put a negative there. Let's say if I had a negative 10, then the opposite of negative 10 would be positive 10, but then the reciprocal multiplicative inverse would be a 1/10. Let's take a look at that one. So an example would be like we just said, if I had y equals 10x, then I would also have y equals the negative version of that, and then the reciprocal multiplicative inverse 10x. Or if I had, say, a y equals negative 9x, then I would have a y equals, because it would be positive, it would be a 1/9 x. Those are some examples there. Part C. Consider the 3 pairs of lines below. All right, so pair 1, pair 2, and pair 3. All right, so what I see here, we have an initial regular equation on top for each of them. Look up down here. We have some extra things to do. If you recall our work with equations in previous problems, we had to do a little bit of some distributive property work in these to simplify these as we go. So it says here, for each pair, graph both equations on the same coordinate axis. And then 2, what do you notice about the graphs of each pair of equations? How might you have predicted this from the equation? All right, so let's take a look at the pair 1 equation. So this one's all set, ready to go. The next one, in this case, we would do some little bit of distributive property here work first. So let's do that. So I'm gonna have my y is equal to, and if I distribute this 2 through, 2 times x is gonna be 2x. 2 times that 1 is gonna be a plus 2. Then I bring my minus 1. If I do a 2 minus 1, that's gonna give me a plain old 1. So I'd have y equals 2x plus 1. Hey, look at that. These two are the exact same line. Let's see if that happens for the other two pairs as well. Pair 2, we have y equals 5 minus 2x, and then we have y equals 3 minus 2 times x minus 1. All right, so that one's there, all set, ready to go. Let's distribute this through. So I got y equals 3 minus, now I'm gonna do this as a negative 2, distributing that through. So negative 2 times x is gonna be a minus 2x, and negative 2 times negative 1 is gonna be a positive 2. So our negative 2x is gonna be the same. Look, I've got a 3 plus 2, which is giving me a y equals 5 minus 2x. And again, look, they're the same. And the last one, pair 3. So I've got y equals 2 times x minus 1. And then I've got a y equals 4x minus 2x minus 2. So got a little bit of work on both of these to do. So first one, we have a little bit of distributive part. So 2 times the x is going to be y equals 2x. And then 2 times the negative 1 is going to be minus 2. And here, I've got a 4x minus 2x. Remember, that's like 4 xylophones. Take away 2 xylophones. I'm still going to have 2 xylophones, and then bring down my minus 2. Look, these are the same as well. So in that case, we did a little bit of work out of order. We kind of did C2 first, and then we're going to go back and C1, and we're still going to graph them and show that these would be the exact same lines. So let's go ahead and take a look at that. All right, here we go. Graphing this one here. So there's the equation for pair 1. So I put 0 in here. 2 times 0 is 0, plus 1 would be 1. And 2 times 1 would be 2, plus 1 would be 3. So let's graph that guy. So 0, 1, and then 1, 3. Be there. And there is our graph. And notice how if we'd have gone in and plugged the same values in for these, if I'd have put a 0 in here for this original equation, that would have been 0 plus 1 would have been 1. 2 times 1 would have been 2. Then minus 1 would have been 1, so I still would have had that same 0 and 1 in that case. All right, so here we go. Plugging in 0 for pair 2. So 2 times 0 is going to be 0, so 5 minus 0 is going to be 0. In this case, if I put a 1 in here, that'd be 2 times 1 would be 2, so 5 minus 2 would be 3. I'll put those same points in there. Actually, I put a 5, not a 0. So it's going to be 0 and 5, 1, 2, 3, 4, 5. And then we're going to have a 1 and 3, 1 and 3. And that's going to come down like this. And remember, we worked out that these are going to be the exact same equation, so we put that graph once. And for our last equation, y equals 2x minus 2. If I put 0 in here, 2 times 0 would be 0, minus 2, so I'm at minus 2. And if I put 1 in here, 2 times 1 would be 2. 2 minus 2 is going to be 0. So we'll put these points in here. So 0, negative 2. And then 1, 0, 1, and 0. So we have this line right here. And again, because it's the exact same equation from our work before, we find out that it's going to be just the same line. All right, so here we go. Hopefully that's all making sense. Let's take a look at our ACE work. Today you're doing numbers 16 through 34. Let's take a look. All right, here we go, 16 through 34. So for each pair of points, exercise 1619, answer these guys. So you're going to plot these points on a coordinate grid and draw a line through them. Find the slope, find the y-intercept of the line, explain how you find the y-intercept, use your line from parts A and B to write an equation for that line. Find one more point that lies on that line. So guys, I understand that we don't have graph paper, And I know that's challenging. So if you end up using some of the other strategies to find the slope of the line, you can do that. Make a table of values, all the different things that we did in the previous lesson, like in 4.2. That's not a problem. But try to do your best. Make a good graph. Use a ruler. Be as precise as you can. Instead of just doing a quick sketch, try to be as precise as you can. All right. 20 to 22. Determine which of the linear relationships A through K fit the description. So you've got A, B, C, D, E, F, G, H, J, and K. There's not an I. So then, 20. The line corresponding to the relationship has a positive slope. Which ones of these have positive slopes? The line corresponding to the relationship has a slope of -2. Which one of these have -2? The line corresponding to the relationship has a slope of 0. Which one has 0? Okay? So it could be multiple letters as well, not just one at a time. Okay? Just keep that in mind. 23. Decide which graph from up here matches these. So there's 5 graphs. Which ones match those? Okay, so you're doing that there. 24. You're going to actually look at all these 3 equations, make a table of values, sketch a graph, find the slope of the line, make up a problem that could be represented by the situation. Again, same situation with graphs. Do the best you can on those. 27. Graph a line with a slope of 3. Find 2 points on the line. Write an equation for the line. Same set of axes, graph a line with a slope of -1/3, okay? So same process, looking at this here. Those are probably going to be perpendicular because they're opposite reciprocals, okay? Use the line there, find the equation that would be parallel to that one, or parallel to that line, or perpendicular to that one. 29, find the slope and write equations for all 3 of these. Compare the slopes, how are they similar, how are they different? And 30. Descriptions of the 3 lines are below. Which of these 3 lines go with those parts there? Suppose the slopes of 2 lines are negative reciprocal of each other. For example, so do that. What must be true? Write equations for 4 lines that would be sides of a parallelogram. Explain what must be true. Write equations of 3 lines that intersect to form a right triangle. Explain what must be true. Describe how you can decide if the 2 parallel lines are perpendicular from equations of the line. So this is a lot. This is a big one. This is getting us ready for the end of this particular book. So if you guys have any questions, please let me know. You can set up a Google Meet. You can email me. You can message me or comment on the stuff in the Google Classroom. But please let me know if you guys have any questions. All right? Okay? Catch you guys next time. All right.